Right, yes, so I'm going to talk a little bit about EVs and what's going on in the trade. So the first question I'm asking with this screen here is, where have all the diesels gone? What's happening in this automotive world at the moment? How many of you are noticing a change? Are you noticing a reduction in diesels yet in your car park? Yes, no? A few saying no, a few saying yes. Yeah. Yeah, interesting. Hang on a second. Let me go over here. So, legislation, emissions, what have you, are all driving the numbers of diesels off the road now. They're getting more and more expensive to repair, and the trend is toward hybrid and electric vehicles. It's one of the solutions. It might not be the solution, but it is one of the solutions. The problem is the trade seems to be scared of them. In the main, we've still got a resistance to EVs. So we get a lot of common issues with the workshops who say they're too complicated. I don't want to look at them, I'll send them on. Or they're too scary, I might get fried. So I'm not interested, I'll send them somewhere else. Or the other one is, I haven't got the equipment to deal with. The thing with EVs is, you don't need a lot of equipment to deal with them if you make them safe. The only time you need a lot of equipment on them is if you're looking at live stuff, you know, high voltage live stuff, or you're delving into the batteries themselves and you've got high voltage exposed. So in the main, you really don't need a lot of equipment. But we have got to try and get over this business of, I don't want to look at them, I'll send them somewhere else. What's really wrong is, we're scared. And why are we scared? We're scared because we've got a lack of knowledge, a lack of understanding of these things. They're really not that scary. But there is too much of it out there, you know, people turning them away all the time. So yeah, one of the biggest things, they're too complicated. We've just had a lovely chat from James. How much complication is there in this bit of a diesel? How many moving parts are there in the engine? I've only put a fraction of it up here. But this is what we've got in diesel engines. We don't bat an eyelid, do we? They come in, we fix them. But they're immensely complicated, aren't they? How many moving parts are in that? There's a few, isn't there? And this system, yeah, again, you can easily get lost in that system, can't you? By comparison, what have we got in an EV? We've got a motor with one moving part. It's the only bit that moves. We've got a battery. We've got a control unit with an inverter in it. And we've got a throttle pedal. And that's it. Why are we scared of them? How complicated is that? What do you think? Does that appear complicated? There's a lot of blank faces here at the moment. Why? Is that complicated? No, it looks quite straightforward, doesn't it? Looking at what was there before, there's not a lot going on with these things. It's not that complicated. Oh, I'll go to that in a minute. Lack of knowledge, lack of understanding. That's a biggie. So I'm going to test you a little bit now on a lack of understanding. How many of us are quite happy to walk up to a 13 amp plug and pull it out of the wall while it's still switched on? Is there anybody here has never done that? Anybody at all that's never done that? Not a single hand. Not a single hand. Right. I wonder whether you'll do it in the future if I tell you that the peak-to-peak voltage of the domestic 230 volt system is 650 volts. Does that surprise anybody? Yeah? If you go peak to peak, it's 650 volts. Because we deal with RMS. The average voltage of the domestic supply is 230. It tends to wander between 220 and 250. But the average is 230. The RMS takes it up to 330. So if you go peak to peak, or 660 if you go by that, isn't it? Peak to peak, 660. Is that a surprise to anybody? Yeah, still very quiet. Not a lot going on here. Did that surprise anybody? Yeah, cool. In all honesty, you're only ever going to be exposed to 330 volts because it passes through 0. So we've got 330 plus, down to 0, then 330. You're actually only ever going to be exposed to 300. But peak to peak, big volts. How many volts do you think there is in the high voltage battery of the Toyota Prius that we saw? Anybody know? Nominally around about the 210 mark. Is it? Oh, I lost it again, have I? Must be. How's that? We back? We're back? Good. Sorry. I don't even notice. Yeah, it's only about 210 volts-ish nominally. That's a huge difference, isn't it? Why are we so scared of the damn things? I accept it's DC, and of course DC you've got the problem where if you touch it, it'll make you grab on, whereas AC you can get away from. So how do we deal with this? We make the vehicle safe. What do I mean by making a vehicle safe? You make the vehicle safe simply by disconnecting the high voltage system from the rest of the vehicle. So if you've never heard of making a vehicle safe, a hybrid or an electric vehicle safe, this is what we're talking about. We're talking about disconnecting the high voltage system. Once the high voltage system's disconnected, is that now going to be dangerous to work on? Shouldn't be, should it? Because one of the things we do in this process before we start working on the vehicle is check for the absence of voltage. And the only safe way of doing this is use the manufacturer's instructions to make the vehicle safe. They all do things a little bit differently. Some of them are much more complicated than they need to be. Jaguar Land Rover springs to mind. It takes about 2 hours if you follow the Jaguar Land Rover process. Hello, lost the back again. And another one of the interesting things is a lot of them require you to remove a high voltage cable, put a breakout box in the middle, and then test, which to me is completely bonkers. Because if you've got to take the thing apart before you can test it, you're taking something dangerous apart, potentially. So it's a bit crazy. So yeah, follow these procedures and you will be safe. So what about these numbers? I'm losing this again, aren't I? What about these numbers? So this is April's sales figures of new vehicles. Nearly 60,000 of them are petrol, just over 6,000 of the diesel. All the rest are battery electric, plug-in hybrid, or hybrid electric. If you add all those figures up, this is something like 55% of the market, this is something like 45% of the market. But the trend is electric vehicles are climbing. We're going to have much more electricity on the road soon. Whether you like it or not, it's going to happen. And that means these cars are going to be coming to you to be fixed. You need to prepare yourselves if you don't. I'm probably talking to the converted here, because I think most of you probably play a little bit with EVs. But as a whole, the trade still seems to be really frightened of them. They don't like them at all. Interesting when we get guys coming on the courses and we chat to them what experience they've had. Very few of them have had experience with them. Even when they come on the training, they get trained and then they don't see one. Or another technician in the workshop gets the job instead of the one that's been trained, which is bonkers, but it does happen. But yeah, we're not going to get away from these things, guys. They're there, and they're going to be more of them. Equipment. I'm sure you'll have various tool companies come round to you and try and sell you great big roll cabs full of EV equipment, so you can go and fix these EVs. Nice complicated stuff. Oh yes, you can't do the job without this, you can't do the job without that. That is probably all you need. In fact, you probably won't use half of that. These sockets are a nightmare, they're huge. If you've got a nice little 6mm bolt down the bottom of a tube, a little recess, you've got all your gloves on, you're trying to undo this little M6 nut or bolt, these things don't work. You have to get a little bit creative then, but it's all about being sensible. If you've made the vehicle safe, you shouldn't need to use this stuff. If you're working on a battery, and you'd have to be a level 4 tech incidentally if you're working on the live stuff. If you're working on a battery, you might need to use some insulated tools, but again, these won't go into some of these places, so this is where you need to get creative. But that's a sort of a thing for you, electrician's gloves, maybe wrapping up your 1/4-inch drive sockets with insulation tape, that sort of stuff, but you're just going to have to be a little bit more careful. Some of them go very over the top when you're doing high voltage repairs, but it's not about it's a procedure that protects the manufacturers. It's not a procedure to protect you. The reason you get all these, you know, you Volkswagen dress you up like astronauts. You have to have special overalls, special gloves, special mats and boots and face masks and all the rest of it. It's for their protection. If something goes wrong and they can say to you, well, you didn't follow the procedure, it's not their problem then, it's your problem. Now the interesting thing is, according to the HSE, there are still no recorded incidents of electrocution from an electric vehicle in a UK workshop. And these cars have been around since around about 2010. I did my first training in around about 2010. So they've been around there for a while. Early training did get things a little bit wrong, and I think this is one of the reasons why people are afraid of the things. My very, very first training on EVs with one of the big brands was the very, very first course they ever ran. So we had 12 or 14 techs in a room with a huge screen, massive screen, this big lecture theatre up at the academy that I was at. And the very, very first thing they put on the board was this massive picture of a guy that had been electrocuted. And he was fried all down one side. It was horrific. One guy just stood up and said, sod that, walked out, didn't come back. He didn't say sod that, he said something far worse than that. But he just walked out. Oh yeah, the scaring was absolutely successful. And then another guy went absolutely green and looked like he was going to keel over. I think they realised in that moment of time they probably didn't have the right technique. It was a little bit counterproductive. People sort of went, oh my God, these things are going to kill us. They won't. What they didn't tell them was that that picture was actually of a guy that had been working in an electricity substation. Got nothing to do with high voltage cars, EV cars. So a little bit silly. Yeah, this is true, yeah. No, this is true, but I have a funny feeling that if there was an electrical death, it would be pretty well publicised. Yeah, I think everybody would know about it. And so far, there doesn't seem to be. Of course, we're talking about reported. There's no saying that somebody might have done something silly and it not got reported to the HSE. So we can't cater for that. If it's not been reported, it's obviously not going to appear in the stats. Is it doing it again? Yeah, yeah. Get some gaffer tape. Hold it on that way. Okay. So to illustrate some of the things I've been talking about, we had a nice incident here. Gosh, that's a bit blurry when it's big, isn't it? We use a Toyota Prius on all the EV training that we do here. Bev, our lovely camera lady at the back there, drives it all the time, so it's a vehicle that's in use, in daily use. But it gets horrendously abused. We do all sorts of horrific things to that car and it just bounces back. It's fantastic. It's a wonderful piece of engineering. But Bev started reporting a little problem with it. We were getting a warning up on the dash. Hybrid system warning. Car still drove perfectly well. No issues. And again, this is where we start talking about diagnosing these things. It's the same diagnosis procedure as if it was that diesel there. You're still going to do the same things with your customer. You're going to sit and talk to your customer. What's your problem? You're going to look into the repair history of the vehicle. You're going to make your own observations. You're going to carry out your initial diagnosis in exactly the same way as you do with that. So you might do some fault code reading, what have you, and then you get some ideas, don't you? You put together some hypotheses as what's wrong with this thing from all the evidence that you've gathered. It's no different to that. It's just an electric car. It's just got a different fuel in it. That's all it is. So we did that with Bev. What's going on? Okay, every time I drive the car, this warning comes up. But not every time, not absolutely every time. But over a period of time, yes, now it's coming up almost every day. And then now it's coming up every time I turn the ignition on. But the car always, or put it in ready mode I should say, shouldn't I? But the car always drove. It didn't give any problems. The worry was the particular fault code, which was for the Interlocks system, I'll talk about the Interlocks system in a minute, meant that if the fault had developed, the car would have been stranded. You couldn't have driven the car any further. So we didn't want Bev stranded. So we started looking into it. That was the warning she was getting. Check the hybrid system, stop the vehicle in a safe place. It's a bit scary. If you don't know about these things, what's your average punter going to do? Straight to the side of the road, isn't it? Ooh, I can't drive this anymore. And the punters have a bit of the same idea, don't they? Oh, it's a high voltage car. I might get hurt. Of course, it's nonsense. There's also an issue that we need to really educate the driving public about their electric vehicles because they really don't know what they've got. A lot of people don't realise that you've got to work hard to hurt yourself from a driver's point of view on one of these things, certainly from the high voltage point of view. So when we went in and did the initial diagnosis, we had these fault codes, P0, A0, D, 350 and 351. And it was an interlock problem, so the interlock was open. So what's the interlock circuit? This is the interlock circuit. We have a power supply. We have a couple of, or three interlock connectors and a few resistors, and it's a very simple bias voltage circuit on this vehicle. So you have an output voltage and basically a voltage divider going to ground. If any of these are open, this voltage floats high. While they're all closed, it pulls it down to about 1.5 volts, something like that. But as soon as there's an open circuit, it goes back up to battery voltage. And whatever's connected on this end, sensing it, puts the flag up and says, I've got a problem. there's a loose connection or something like that. Anyway, to begin with, we were a bit lazy about it. I said, well, this car, we had the interlocks off so many times, let's fix the interlocks. So, should have been doing this while I was talking to you, because I didn't do it earlier. What are the interlocks? Where are the interlocks? Thank you, Rob. So on this one, there's only 2 interlocks that we get involved with when we make a car safe, when we make this car safe anyway. One of them is in the high voltage battery. You've got something called a service grip plug. When you pull it out of the battery, that separates the connection inside the battery, so the series connection of all the cells is broken. Can't get any current flow. And on the inverter, we've got this little fella here, which joins a plug down inside there. So if we can go back to the, so the one we're talking about here is in the inverter, and that one is in the battery. There is another one that sits behind this plug here, which is the main DC input to the inverter from the battery, but that one never gets disturbed. So as a preliminary, I went round, we had a couple of these covers. I found the best cover. I did a couple of quick checks and thought, no, I'll just replace that cover and I'll replace the service grip, because we had a spare service grip in. We just plugged them in, cleared the faults, let the car go. But Bev reported just a couple of days later, no, I've still got the same issues. So we had to have the car back in again and start looking at it. Being a bit lazy, we decided, okay, just quickly bolt that one on. So we took the inverter that we've got off this stand here, threw it in the car and tried it. But no, there's a mismatch and there's a problem with the CAN bus in that. So it came out again, we put the other one back in. Not the right way to go about diagnosis, guys. Oh yeah, we worked out what was wrong. We knew where the issue lies, but we didn't want to get into fixing it. We just did a few things first, and we threw that on to try, but it didn't work, so we put the old one back on again and decided we'd had to put some time aside and then properly fix it. So, just showing you some pictures here. This is the interlock that sits in behind this high voltage cable here. So we've got the end of the cable just there, and we've got the socket inside the inverter there. That's the one in the inverter. That is the one in the high voltage battery. So we've got those 3 there. Other manufacturers do things in different ways. This is a BMW connector. You have to remove the interlock loop before you can pull the plug off and separate the plug. Lots of different ways of doing it, but essentially the same system. This is a biased voltage system. There are other ways of doing it. Some manufacturers have a signal generator and a signal generator receiver. You put this waveform out on the interlock and the receiver says, yes, I'm receiving that waveform. Now the nice thing about that system is it can do a little bit more than a voltage bias system can, because if I was to short this to earth here on a voltage bias system, can't see it because it goes to earth anyway. So if that interlock was out but this was shorted to ground, we wouldn't know. In the main, it's no problem because they don't give trouble. They're very reliable. It doesn't need to be that complicated. It's just some manufacturers go a little bit overboard about these things. Yeah, but the nice thing about the frequency, putting a frequency around, is if there's any interference in the frequency, if it goes to ground or it goes to high, or there's a high resistance somewhere, it will attenuate that signal. So if the signal output is in one form and the signal received looks different, it then puts the flag up. But it's essentially doing exactly the same job as the voltage bias system. This is good enough, guys. The other's a lot more expensive. So most of the systems seem to be bias type system. Yeah. So yeah, as I said earlier, initially we just replaced this, we replaced that top cover, sent out to try it, but we still had the issue when it came to it. So I dug into it a bit deeper. I started doing a bit more diagnosis, and I did some sensible, we did some pin drag testing. Do you all do pin drag testing when you're working on control units? Have you got problems? Yeah. You all know that this problem exists, or this technique exists? Yeah, a few nods. Okay, we've got a pin drag test then. You have to have exactly the right terminals. That's the important thing, guys. You can't just go and stick any old pin in any old hole. If you've got a